Okay, I think we'll get started. Okay, so hello everyone. Welcome to the November Spin Developers Community Meeting. Today we're going to start off with a demo by Kate on authentication component. Uh, so Kate, I think I already opened permissions for you to share your screen and things, so you should be able to get going.
Great. Thanks, Melissa. Hi, everyone. My name's Kate. I'm one of the engineers at Fermion. And I'm going to go ahead and share my screen. Okay. So what we're going to demo today is basically with the component model, we have this concept of being able to have ubiquitous components that you could kind of compose into any application because they're so multi-purpose. You can think of them almost as libraries. And one thing that we need in a lot of our applications is authentication. And so Brian Hardock, who's actually on this call, and Michelle Donani put together this authentication component which you can use and compose with business logic in order to have authentication in order to use your business logic. So just to see where you can use this, I have the developer meeting notes here, but next door, we have the repository that kind of walks through how you can do this yourself after this demo and in the future. And then we also have a blog post that kind of walks through why this is exemplary of how you can compose components with Spin 2.0. So one thing I want to show before we dive into the demo is kind of what Spin 1.0 looked like. And in Spin 1.0, you would have your spin.toml where all of your components were separate in that spin.toml. But more importantly, behind the scenes, what was happening in Spin 1.0 is when you use one of your components, it's a separate HTTP request. So if your components were communicating with each other, they had to go over the network to do that. So say you had some business logic that also needed to use GitHub OAuth to permit access to it. Those would be two separate components in Spin 1.0, and you would have to separate them in your spin.toml. What Spin 2.0 provides is a way to run WebAssembly components in your Spin applications. And so those two components could actually be one component. And we can look at the spin.toml here. You can see we went from two components now to we have one component. And if we look at kind of diagrammically what's happening here, in our scenario where we have one business logic component that is composed with authentication middleware, here you can see that we have them composed together to create one composed component, and that is composed with the Spin runtime. Which is the WebAssembly host, which has those host components that it is, and it satisfies the imports of the finalized component. So what are the imports and exports that be in this demo? So right now in this demo, what we have is we're passing an HTTP request from component to component. So the Spin runtime will pass that HTTP request to the authentication middleware, which exports incoming HTTP handler, which is a WASI interface that defines HTTP types, and it expects that incoming HTTP request. And then once it
Kate,
authenticates, yeah.
sorry, just wanted to say we're just seeing the README right now.
Okay, great.
So
I was wondering if that was the case.
yeah,
Um,
so
Interesting. Okay.
Did you mean to share your whole screen rather than just
I
one
did.
window? Okay. I don't think that
Um,
happened for some reason.
Great. Well, I'm hoping my words are very descriptive. But this is what I was speaking to. So I'm just going to recap real quick. So Spin 1.0, you had two components defined in your spin.toml, each one sitting on a different endpoint and each one communicating across full HTTP requests. Spin 2.0, now we have this one composed component. But what does that component look like? Well, in this diagram, you can see that that component is actually two components composed together across an interface, namely WASI incoming HTTP handler. And we're seeing that we're passing that incoming request from the Spin runtime to the composed component with the auth middleware receiving it first. And then if it authenticates successfully and only if, will it pass that incoming HTTP request to your business logic. So if you want to read more about that, we have that in this blog. And now we're going to jump back to the code and see what's happening there. So, as you could see kind of um, in that little diagram there, we have these two components. So one is the um, GitHub OAuth component, which is that middleware that we were talking about. And the other is our example component, which is just example business logic. And let's first go in there and see what all it is. And all it is a spin component with an HTTP trigger that literally says, I executed my business logic. So if we see this line like in the browser, that means that we've authenticated and got to our business logic. If we look at the spin.toml of that component, you'll see that it's using Spin 2.0 and that it has very similar to that blog. You can see it just has one component, and it is that finalized composed component. And it has some environment variables to access the OAuth, GitHub OAuth client ID and client secret. And we'll walk a little bit through what that build script is in a second. So I'm going to go ahead and run the example, and then we can go a little further. But the one other thing to mention is this GitHub OAuth component basically just follows the GitHub OAuth protocol. So you can create GitHub OAuth apps, and it expects a certain authenticate, authorize flow with callback URLs. Great. So when we're doing this, there's multiple different ways to handle the client ID and client secrets when building this demo. What we're going to do first is just be able to pass in environment variables to spin at runtime, which is an ideal scenario. We don't want to it's ideal not to embed it into the WebAssembly binary, which we may have to do a little later, depending on how much time we have for the demo. Great. So the first thing we're going to do is we're going to build that middleware. So to build the middleware, we're going to use Cargo Component, which is Bytecode Alliance Upstream's tooling for building components in Rust. And our OAuth component is in Rust, so we can go ahead and use Cargo Component. So now we've created this GitHub OAuth.wasm component it exports a WASI incoming HTTP handler. Let's go ahead and it also imports one. Let's go ahead and also build our spin application. And if we look at this build script here within the spin.toml, you'll see that it's doing a few things. So the spin.toml runs this build script here. And what that build script does is it basically, we'll do this, go ahead and do this step by step, actually. We're going to first build the component because this spin app actually is a component as well. And now this is the important part. We're taking that GitHub OAuth component and we're composing it with this example business logic. And we're outputting that final service.wasm that our spin application will serve. So you can see we've composed that final service.wasm. And if you look in the spin.toml, you can see that that is what spin is going to serve as its component. And we'll go ahead and do now when we do a spin up, we're going to actually pass in our client ID and client secret for our GitHub OAuth middleware. Okay, so now we have our component. Make sure I'm sharing the right screen again. Okay, so let's go ahead and try it out. Can you see my incognito tab here?
Yes.
Great. Cool. So the first thing I want to check is that we don't have any cookies here. So we get the full flow. Looks like we don't, so we can go ahead and log in. Here we're prompted to log in with GitHub, so do that OAuth loop. I'm going to go ahead and log in. Mhm. Right, we're doing some authentication here. Great. Okay, looks like we have an error. Love that. Let me make sure I set those environment variables correctly. So let's go back here. One moment. Check if my secrets are exported correctly. Oh, I think I have an idea what's happening. Okay, great. So I think what happened here is that I had the environment variables potentially there. It was being this auth callback URL was being pulled from the spin.toml here instead of the default being used. So essentially, it was trying to use the wrong callback URL. So one for a deployed app that we'll show later. So let's try this again and just see if with that commented, we're in a better shape. So let's go ahead and refresh here. Looks like. Well, we're having another error here. Okay, well, let's see. I might have misconfigured my callback URLs, but let's try something else. I'll try one more time. And just for sake of demonstration, I'm going to go ahead and show the finalized example, which we are going to deploy fresh, but we can go ahead and just show what it looks like in the full loop. Oh, we're really on a roll here. Great. Oh, sorry, we just want to do the app. Okay. So in the full loop, what we'll get is we'll authenticate and then we'll authorize your specific GitHub account. And what this is basically saying is for this OAuth app, I'm authorizing that it uses my email only. So that's what we decided our GitHub OAuth app would use. And then we'll authorize and it'll show you your business logic. So that's one that is using, that's one that's deployed to Fermyon Cloud that does this flow. Let me just go ahead and try one more time with the local experience. Mhm. Okay. Um, cool. All right. And then we'll go back to running our steps. So once again, the first step is to build your component. I did a clean build, so it's going to take a little longer. And then we're going to go ahead and spin it up next. And we'll see. So with this component, you really have to be, as you can see, we're struggling. You have to be careful about, I'm toggling between different GitHub OAuths, one that does like a local host callback and one that does one for a app deployed to Fermyon Cloud that we saw. So I have to make sure the secrets are set up correctly. Let's see if we have it set up this time. And we will go ahead and try it out again. Do a new incognito window. Great. Oh, looks like it had the cookie still. All right, I think I might call it on this, but let's see if we can. Yeah, looks like our demo is not working the best there, but if you are watching along, go ahead and try out this one, the one deployed to cloud, which is the same flow. And you can walk through seeing how it'll authenticate and then go to your business logic. The one thing we did prove is that if you don't authenticate, you don't get to see your business logic. So unfortunately, that was the lesson that we promoted in this demo. But definitely try it out. Set up your own GitHub OAuth app, get your secrets correct, and you should get the flow working on your side.
Right, Kate, thank you so much. I know demos are so hard, so I appreciate your efforts in demoing it. And I believe we've got some questions in chat. So
Yeah,
Steve asked about, go ahead, Joel.
I might chime in. Yeah, so Steve just asked about being able to call out to a WebAssembly from one WebAssembly component to another one, get the response, and then I assume, Steve, maybe you might want to modify that response before sending it back to the client, or do something like that.
Right. Yeah. I'm doing that
Yeah.
today, but I'm doing it over HTTP. So I spin
Sure.
up like
Yeah.
a dozen components, and I call out and go back and call out and go back and parse responses and all that. Yeah.
Yeah, great question, and definitely, yeah, great question. There's kind of a long answer and a short answer. The short answer is there are limitations to the current state of WASI HTTP and WASI Preview 2 that make that challenging to do from a component composition perspective. So our plan right now is to actually essentially, so what you're doing right now is basically making an outbound HTTP request to another component, and then getting the response back, and then forwarding the response back to the client, or possibly with some sort of modification before or after that outbound request. Because of those limitations, which I can go into excruciating detail if you want, but for now, there are limitations. Our plan right now is to actually optimize that case of making an outbound request and recognize you're actually just making a request to a local component, and make that not go over the network, not do any system calls, just do essentially an in-memory pipe from one to the other. And that's unfortunately the best we can do. It'll be extremely efficient to do that because we'll recognize, oh, this is a local request, no networking needed, no TCP, none of that overhead. When WASI Preview 3 comes around, the component model will have first-class streams and futures, which will make that possible to do in a composition perspective. The other thing that Brian is working on is essentially creating a unified composition language within the Spin manifest so that you can essentially the intention is that it will choose composition where that's appropriate to essentially, where the limitations of WASI Preview 2 aren't an impediment, and then fall back to essentially using this optimized outbound HTTP request method in the cases where Preview 2 limits us to doing that. Does that help?
Yeah.
Okay.
Yeah, that's what I thought. Yeah, because I get enough excuse me, enough components now where it takes a few seconds for Spin to even start, because it's got to spin up all those servers, I'm assuming. So and most of my logic is just a library like you're describing. So ideally that'd be perfect, but I get it. It is what it is. I was just curious of where it was today, just so I understand.
Where it is today, like right now, is not ideal, and what you're doing is the best you can do. We're hoping in the very near future to have an optimized version of that where there'll be essentially no noticeable latency. The intention is that we will, because you've declared what you want explicitly in Spin manifest, we'll actually spin up those components in parallel before you even do the outbound request and then of course cut out the network, do it in a memory channel. So it should be effectively as efficient as our Dream Preview 3 scenario, but just using kind of, kind of cheating a little bit, if you will, if that makes sense.
Yep, absolutely. Yeah, awesome. Cool. Thanks, y'all. Appreciate it.
Great. Okay. Now we're going to move on to announcements. So the first thing I wanted to announce is that we will not have a Spin Developers Community Meeting in December, being that it's at the end of the month when all the holidays happen and very few people will be around. So we'll pick up again in 2024. And then Karen, you want to talk about the upcoming events we have?
Sure. The first one is, I think, right now. So if you're at this meeting, you're at this meetup. But Mikkel is speaking at the Stockholm Cognitive Meetup today on server-side WebAssembly that's been. And then later this week, Sohan will be at KCD Utrecht. So this is the same. This is a conference put on by the folks that do KCD Amsterdam. So it's just a different city in the Netherlands. And Sohan will be presenting on, well, you can read the title, a greater cost-effective cloud with serverless WebAssembly. And then he'll also be presenting that same talk at KubeDay India. That's in Bengaluru on December 8th. That's next Friday. I didn't add it yet, but we're working on possibly adding a meetup on that Saturday, December 9th, also in Bengaluru. And then the week after that is AI.dev. This is co-organized with Cassandra Summit, and it'll be in San Jose on December 12th to the 13th. Matt Butcher has a session, and then Fermion is also sponsoring, so we'll have a table there. And I think that concludes all our events for the rest of the year. Thanks.
Thanks, Karen. Okay, and then for calls to action is just building those components and getting us the feedback on what you'd like to see improved, and also some show and tells on what cool things you've built with components. So that's the end of our formal agenda. Now we get to open up the floor for any other questions, anyone who wants to introduce themselves or discussion topics, anything like that.
I guess I could very quickly mention that my current project is working on adding TCP socket support to Spin, and more specifically, actually, it's almost just flipping a switch in Spin to actually enable that. The more important part is making it ergonomic and allowing to use your programming language's standard library and the ecosystem of libraries that are built on top of TCP, say database drivers. If you want to use MongoDB or something like that, you will hopefully be able to do that sooner rather than later. I've got some prototypes that are looking very promising right now. So I'll keep folks posted on progress there.
Awesome. Thanks, Joel. Anyone else have anything they want to share? All right. Well, if no one else has anything, then we'll wrap up the call. Thanks everyone for joining, and we'll see you in 2024.